Hello everyone. So today we are solving a question of JEE ADV 2017 from the topic of ray optics. So let's first read the question. It says that they're given an isosceles prism of angle A and refracting index of mu. So we have to, it is found that the angle of minimum deviation is delta m equal to A here. That is the angle of prism only. We have the following options is are correct. So let's first draw the diagrams and all. We will draw the ray diagram first. So this will be our prism here. I don't know what color it is coming. We can do it with this. Okay. This is our prism here. And now we need to draw some, this is the perpendicular. Here, this will be the incident ray. And one thing I want to let you know this, whenever there is an angle of minimum deviation, this line is parallel to the baseline. Okay. This also is one of the option here. So I'll prove it to you. Now this is I. Okay. And this is the E, that is the angle of emergence. This is angle of reflection 1, angle of reflection 2. This is the angle of A, and the mu will be the refractive index here. Okay. So what formulas I'll be using here? Let me write all this first. First is that's the angle of deviation, that is delta m, not delta m. M is representing the minimum. It is always equal to I plus E minus A. Okay. And another thing that R1 plus R2 is always equal to A here. Okay. I think this would be enough. And one thing that everybody knows here, that is Snell's law, and one sine I is equal to N2 sine R. Okay. This formula, these three formula I'll be using there to solve all the questions here. Okay. So let's first see what we have to find here. So angle of incidence I1 equal to A. So we have to put I equal to A, then to check whether the line is parallel or not. We have to find relation between A and mu here. And we have to check what R1 is, whether R1 is equal to I by 1 by 2 or not. And this relation we have to find out. Okay. So let's start solving by putting the Snell's law here. First of all, it is given that delta m is equal to A here. And we know that angle of minimum deviation, at the angle of minimum deviation, I is equal to E and R1 becomes equal to R2. So using this, what we can do here is delta m is equal to 2I minus A. I can write I equal to E here. And A is also equal to delta m. So we can write delta m equal to A. So 2A equal to 2I, that is I becomes equal to A here. So at the angle of minimum deviation, I is equal to A. This is our first option, saying that when incident will be equal to I equal to A, the ray inside the prism will be parallel to the base of the prism. This is absolutely correct, because I have told you at the angle of minimum deviation, this line is parallel to the baseline. Okay, so we can mark our option as correct. Now we have to find the relation between the prism and the refractive index. Okay, so we can find this using our Snell's law. So before this, we have to find one relation between R1 and A. So I have told you R1 plus R2 is equal to A here. So as I equal to E, R1 is also equal to R1. So we can write 2 times R1 is equal to A. That is R1 is equal to A by 2. Now if I write Snell's law at this point, okay. So I'll write 1 into sine I, 1 is the refractive index of the air, sine I, this is equal to mu times sine of A by 2. That is our R. And I can also replace I with A here. So I will write sine of A by sine of A by 2 is equal to mu here. If you look at this properly, we can break it into 2 sine A by 2 into cos A by 2. If I write like this, so mu equal to 2 sine A by 2 into cos of A by 2 divided by sine of A by 2. If we divide this, we will get that mu is equal to 2 times cos of A by 2. If we do all the calculations here, so we will get A is equal to 2 times cos inverse of mu by 2. Okay. So let's see whether it is our matching or option or not. So here is written, it is written as half time cos inverse, but actually there is 2 times cos inverse mu by 2. Hence our option B is incorrect here. Moving on to option C here, at the angle of minimum deviation, the incident angle I1 and refracting angle R. So actually we have proved this question earlier also. Like if you look at it there properly, I have written I1 equal to A and R1 equal to A by 2. So I can write like uh, R2 by 2, sorry, 2 times R2 is equal to A. So the R2 is, or the R1 is equal to, what am I doing? R1 is equal to I by 2 here. We can write it like looking at this. So here this is actually correct here. So we can mark our option C as correct option. Now for the prism, when the emergent ray at the second surface will be tangential. So when the ray becomes tangential at the angle of critical angle, if you know the concept of Snell's law, Snell's window and total internal reflection. So suppose this is the surface of N1 and N2. This is the normal line. Any ray incident at the angle this, and it moves on tangentially. That is, I cannot show you this. It is moving like this tangentially to the surface. This angle is called at the critical angle, that is theta c. It is generally equal to sine inverse of n1 by n2. Okay, so let me erase this. We will use these concepts here to solve this question. So we have to tell the relation between I and A. Okay, so we cannot use any other term. So how we will relate this? First of all, yeah. So what we can do here is at that surface we can write for R2. So mu times sine of R2 will be equal to 1 times the sine 90. So we can find R2 is equal to nothing but sine inverse of 1 by mu 2. And we will know that R1 plus R2 is equal to A. So we can write R1 is equal to A minus R2. And we have a relation between R1 and I1. If you know, like we have found it earlier also here at this point, like putting sine I and this things. So let's do it again. So we will get 1 times sine of I should be equal to mu times sine of R1. We can replace R1 with this. So sine I should be equal to mu times sine of A minus R2. Now we can break it into sine A minus B formula. So mu times, what is sine A minus B? It is nothing but sine A cos B minus cos A sine B, that is sine R2. Okay. Now, if you look at the question, there is nothing, no terms of R2 and mu here. So we need to remove all this by putting the relations that we have found earlier. So we can write sine of I should be equal to mu times, we know what is R2. R2 we have already found here, or let me write sine of R2 should be equal to 1 by mu 2. And what will be cos of R2? Like we have to replace both of them. So what will be cos of R2? It is nothing but root under 1 minus, why am I writing like mu 2? It is nothing but mu 1 minus 1 by mu square. Okay. So I can write like this. This is equal to cos of R2. So if I replace this sine of A into root under 1 minus 1 by mu square minus cos of A into what is sine of R2? It is nothing but 1 by mu. So you can see that we can take 1 by mu common from here. So if I do this, sine of I is equal to mu times 1 by mu common sine of A into root under mu square minus 1 minus cos of A into 1 by mu. So you can see that this mu can cancel all the inside mu's. So sine of I is equal to sine A. Again, we have a mu here. So how we can replace this mu with some terms of A? I think we have found this relation earlier. Yeah, here is the relation. We have to put mu equal to 2 cos A by 2. Okay, so let's put that. So we can write what is 2 cos A by 2. It was, so we can write it 4 times cos square A by 2 minus 1 minus cos of A. This is equal to sine I. So I is equal to nothing but sine of inverse of sine A into root under 4 cos square A minus 1 minus cos of A. Let's match this to our option. C, every term is matching here, so we can mark our D as correct. So our correct options are A, C and D here. Thank you everyone.